need your help. I need you to hold this meter stick up like this. Okay? Now, what I'm going to do is I'm going to take this light, I'm going to shine it on this angle, and I'm going to take this and continue this on. Okay? So if I maintain that same angle, if that light travels in a straight line, it should hit somewhere out here. Okay? So I'm going to shine this light, and it should hit somewhere out there if it travels in a straight line. Okay, ready? Good. So I'm going to shine that kind of parallel with that. Now, where's the light hitting?
Over there, on the floor.
Right there. Right there. If it went in a straight line, it would hit
Right there.
way out there. So we're here, right? Okay? And that light is hitting
Where's it hitting?
right there. So it's hitting here, okay? But if it didn't, it would hit
Going like right here.
way up there.
Going like right here.
So here's how you can visualize this, how this is happening. You're traveling through air. It's going to hit the water. What's it going to do? Speed up or slow down?
Slow down.
Slow down. So here's how you visualize this. So imagine these are the wheels of a car. Here's your axle, and you have wheels on either side of this. Okay? This is driving on like dry pavement. Both wheels are spinning at the same rate. Okay? Now, this is like thick snow. Okay, we'll go with the weather that we have. This is like thick snow. So you're driving along. This side is going to hit the thick snow first. What's it going to do? This is going to slow down. So this side is going to slow down. So what's it going to do?
Turn.
It's going to bend it like this. Okay? So when it hits this water, it slows down. That angle gets bent, and that's why it hits here. Okay? Now, if this was snow, visualize this is snow, and this is dry pavement, and you sped up. If that was the case, that this came in here, and it actually sped up when it hit the water, what would happen? It would go like this, and then it would end up way out there. So this angle, this is going to be that angle of incidence. So you imagine that you have a normal line right here. So the light's going to come in here, it's going to hit this. It's water. It's what we call more optically dense. So what's it going to do? It's going to slow it down. As it slows down, this side hits first. Wavelength gets shorter or longer? Shorter. Wavelength is shorter. It bends that light. It accelerates because what's it doing? Slowing down. Slowing down. So it hits here, boom. That's why that light hits here instead of going in a straight line. Now, remember what we did with the test tube and the oil?
Yeah.
Okay? It looked like it disappeared. Because the index of refraction of oil is the same as the index of refraction of glass. So if air and water had the same index of refraction,
then it would just go in a straight line.
then it would just go in a straight line.
But it's not.
Now, what do you think is going to happen to the amount that it bends if the index of refraction of water is much, much bigger than air? So in other words, if there's a bigger difference between the two indexes of refraction, what's it going to do? Bend more, bend less? Bend more, because of the fact that now, if there's, then it's just like, ooh, you really slow down, and it really gets bent. If there's just a little bit of snow, and there's not much slow down, it's not going to bend as much. So the bigger the gap in the index of refraction between where you are and what you're going to end up in, the more it's going to bend. Now, what if I did this? What if I shined the light and I had it underneath the water, and I was shining it from the water and having it go into the air? So imagine that it's coming in. Okay? So I shine it like this, and it's going from the water into the air. It's going like this. What's it going to do?
Flatten out.
Will it bend flat?
It'll bend
Or
flat.
will it bend up?
Flat.
I think it'll bend that way.
Flat.
So it's going to be coming like this. What's going to happen to this side?
Oh, it's going to
The top is going to go.
The top is going to,
Go faster.
Go
it's
fast.
going to go faster,
The
right?
bottom is stuck.
So if that speeds up, it's going to flatten that out,
That's what I meant to say.
So instead of hitting like up in the corner, it would hit at some point over here. Okay, got it? Good, Grant? Back again.